I actually started playing with electronics when I was 8. It was a Philips electronics kit. And there are any number of people I meet and I talk to them for the first time about how they started their career. And an awful lot of them started with some sort of electronics kit. Now, I was born before the first satellite went up in space, which still makes me think, how could surely that was prehistoric. And the reason that I think that, well, I have lived with Moore's law all my working life. So constant change is the norm. And if you don't do that, you're going to stagnate and go backwards. And I think you can see that, and I've got an example of it, but you can see that Acorn was driving behind Moore's law, or following Moore's law, and indeed it was the fact that they were starting to use semi-custom techniques ahead of, or unexpectedly for such a small company. Actually, in my case, I became disillusioned in my teens with electronics because it all turned into these little plastic packages. And what's the fun of putting a few plastic packages together? You know, I liked the designing, making the same bag of bits do different things. And when I came to go to university, it's like, what am I going to do? I literally applied for mathematics, for computing and economics, for electronics, and in the end I did physics, not because, just because it's a general degree, you know, I could do lots of things with it. Probably a bad idea. The way physics was taught to me, so I didn't go to Cambridge. I thought they were a fuddy-duddy sort of place, you know. with rude people who heckle from the back, and front.
From the front as well.
Yeah, that's what I just said. Anybody in the middle wanting to heckle? I take heckles as well. And
I'm with you.
well, I did a 4-year course where I worked in industry for a year. And that was really the spark that led to me being here where I am today. I went to work for a company called Plessi. Some of you might have heard them. They still exist, but they're not the same Plessi as was. And I ended up at their research centre in Northampton. I didn't know where Northampton was. And you used to see signs saying Nupton. I thought that was a different town until someone pointed out, no, it's the same place. It just doesn't fit on the signs. And it was fantastic. There were about 600 people there. They got pure mathematicians. They got a workshop with, for the time, pretty interesting mechanical tools, you know, for cutting and building things. We had a couple of fabs in the next door building. When I say a couple, they could do CMOS, they could do TTL, they were doing gallium arsenide, they were doing indium phosphide. And it's like, and they built a lot of their own equipment to design chips. So they'd got people who were building testers, people who were designing some of the software that we later went to use, things like simulators that Lee knocked up for Steve. But it was just like, that's, you know, real men don't eat quiche. Real semiconductor companies, in my mind at that time, they have all of the bits that you need to do it. And so after I finished my degree, they gave me a guaranteed job, and I could have probably failed and still got to work there, but I don't think that would have been a bright idea. And it was brilliant. And they were doing all sorts of things. I got lots of opportunity to design different circuits, and I took a chip down into production. And that's, I think, when I was starting to think, well, this is a bit weird. The production people didn't really get on with the R&D people, and it wasn't clear to me what Plessi was all about. And if the bosses came to visit, they'd fly in the helicopter, run through the lab, go into the canteen. It wasn't a canteen, it was a posh place. Drink as much as they wanted and then fly off again. And it sort of just didn't feel quite right. But what I did learn is every year things were moving forward, and because it was a research fab, we never got all of the full information about what you could buy, what are the parameters of the processors we were using, And even better, if you got something you designed, instead of having to pay for it, you could pop down to the fab and, do you want to run this as a test chip? Which was great. It's like, you feel part of one big team, which is really nice. But I was disillusioned by that. But at the same time, I was getting interested in. I was using a Commodore PET to do chip testing, and it's great fun. It was very slow. I rewrote a lot of the relevant bits in assembler, which I say assembler, it was hex, which was very, very painful. I only remembered that the other day thinking, God, yeah, it was. Anyway, it worked, it was good. And my brother, who had done electronics, he was probably more sensible than me because that's what he liked to do. He had gone back to university because he wanted to be a student again. And he was doing a postgraduate certificate of education, PGCE. And he said, oh, look, I'm trying to write a program to teach kids about wavelengths, frequencies and such like. And, you, on the beeb, we could do it so that it's light or sound. Okay, what's the problem? Well, it's just not fast enough. So I took a week's holiday. He came up to stay with me. And I was married at the time. And I bought a beeb. Which was very expensive. I worked for Plessi. Plessi didn't pay lots of money, and so it was quite a big chunk of the budget. And we just bought a house, and I don't believe in borrowing money, and so yeah, it was quite a stretch. But I was really impressed. I probably shouldn't say this because I don't want Sophie and Steve to get too proud of it, but it was really impressive. The things they thought about, the way you could use it, the way you could write programs. I saw an advert in the press for a chip designer for Acorn. I thought, well, that's a bit weird. Anyway, sounds like a good thing. So I went for the interview in Stevenage, and you're probably thinking, I didn't know Acorn had a Stevenage office. They didn't. It was a couple of recruiters. And I basically played sort of bingo with them. Do you know what a PLA is? Yeah, I know, blah, 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 blah. What other things? And I just I was working as a chip designer. I knew what I was doing. And they, after, 50 minutes, yeah, you seem to know what you're talking about. We'll recommend that you get an interview. And then I drove home thinking, I'm not very impressed with that. But when they offered me no, they didn't offer me a job. They offered me an interview. I went over, and it was just before the Silver Building in Cherry Hinton was finished, and I went to Market Hill for the interview. But we went up to the person who interviewed me was a guy called Mike Hill. We went into the building and said, "This is where it is," and proudly showed me they'd cut a hole in the floor right through to the foundations, and there was a big marble slab on it, and there was a little probe station in microscopes, or a microscope, and little probes you could probe down onto the surface of the silicon. Wouldn't tell me what they were going to do. When I went back to Plessi, foolishly they didn't tell me not to talk about it. So I said, I think they're building a microprocessor, a 32-bit microprocessor. Don't be stupid. They're never going to do it, because at that time there was a group in the lab I was in doing that along with ICL, a computer company some of you will have heard of, but no longer. Well, they became Fitchits, I suppose. And anyway, I joined on the very first working day of 1984, an auspicious day, to find that actually the person I thought I was going to be working for wasn't, and some new person had joined, and yet another person was involved. And yet we only had one computer. The guy that I was working for, very bright, and what I discovered is there was quite a lot of thought about aspects of the design, but we had no sort of design methodology. And ultimately, if you're ever going to be in chip design, you need a design methodology. How are you going to get from A to B with all of the steps you need on the way to ensure that you make it successful? We shared this one computer, an Apollo DN600, that was remarkably unreliable, and sometimes if we got them out to fix it, they'd bring a selection of boards, and these boards were sort of so big, and pull them out and change the permutations until it's like, yes, it's working again, you're okay. Not how to build a computer, in my opinion. And I used to get in at 5 o'clock. Then the second guy would have lunchtime, and then the third guy would come in, and then any jobs we needed to run would run in the gap between. And I remember sitting at my desk thinking, I get paid for this. This is brilliant. Oh, I forgot to mention that when I was asked by the HR lady what my salary expectations were, when I got the offer, it was more. Obviously, I'd come from such a poor background, Plessi not really paying much. And the reason I'm being a bit negative about Plessi, although I got a fantastic education, the shame is the UK was leading in semiconductors, and Plessi it basically disappeared. When I left Plessi, I was this doesn't sound very exciting really, but when I left Plessi, I was working on 1 micron technology. I know you might think it should be 1 nanometer, but anyway, it was 1 micron, state of the art. When I joined Acorn, I ended up on 3 micron, which is like 9 times worse in terms of area and performance. It's not 9 times worse in performance, but it was like going back in time a little bit. But we allocated, so we worked with Steve. He was our principal interface, and the design was split. Have you got a picture of your? It's in the. It's.
There is a floor plan in the.
No, I'm thinking of on a piece of gridded paper. There's a map of where things were, the ALU and such like. They thought about how the register file, not the register file, they thought about the data bus and what the pitch should be. For some reason, we were using Pascal. He wasn't using Pascal. We were using Pascal because that's what the guy's favorite language was when I joined. We had 2 different systems. We were using Mentor graphics for schematics and logic and such like. And then we were using VTI or VLSI technologies. Pretty good design system, but by today's standards, very basic. But what I will say is, before I joined Acorn, basically these were my tools. Spice, if you've heard of Spice, and I literally laid out chips at a drawing board with coloured pencils. That's supposed to be a bipolar transistor. It isn't, but you don't need to do anything to it. We didn't have any DRC. We didn't have, and when I got to Acorn, at least the design system was good, except that we only had 1 design system between 3 people. And there were some bad bits, but there were some good bits. And we also used VLSI technology to fabricate the chips. So it made life easier. They'd done some chips for the Beeb. They'd replaced the Ferranti ULAs, I think, and they'd all worked, so they were happy there. I have a different story that someone's told me, but I'm not sure I should say it here. It's not a bad story, it's just a story about, some delivery of chips. Not our chips, they were chips for another part of Acorn's, what Acorn were developing at the time. And so we evolved a methodology, and it was a methodology where we carve up the chip into pieces that were logical to Steve, but also logical to us in terms of designing them, making sure the interfaces were going to work. And it sounds straightforward, but if you think about it, he had to think about what was going to be the sort of complexity of the logic that was needed to implement what he wanted. We had to think about what the chains were going to be. In hindsight, it was a great idea, but it was, and I don't know, you might know the answer to this, Steve. This is where I get to ask questions of the audience. We decided it was going to be full custom, which was great for me because I was a full custom chip designer. But it was going to be full custom, which gave us immense amounts of flexibility. We did everything, including the bomb pads, which meant that later on when ARM was formed, we owned our own IP. So we were able to just take it. We didn't have to work with a special fabrication company, a fab, I want to say there. And it's some of the choices you make look really powerful, but they're a little bit by chance. Now, my view on why ARM is so low power is, now that's a ceramic chip. It's quite a weighty thing. It probably costs, I don't know, $10, $12, or it did in those days. A plastic chip costs less than a dollar. And our target was to get into this plastic chip because it might not sound it, but $10 is not something that that could be born in terms of the Archimedes computer that was going into. And we thought about it. We had ideas about what we were going to do. Steve would do simulations where he could try and exercise all of the nodes in the circuit. We had a circuit simulator of sorts, but we didn't have any real way of estimating the power beyond trying to sort of guess, well, if it's going to run at this frequency and this is the sort of capacitance, well, maybe it's going to be this. And so he did, and we did. We talked about this, but we also put in techniques to reduce the power. Now, the great thing is, if you look at the design of something, risk is all about, well, it's about reducing the instruction set, but it's also about, in my mind, simplifying. And the simpler you can make it, the easier it is to tailor your transistors to the sizes they needed to be, and so you don't waste power. If you use, nowadays, people will give you cell libraries that are fast and power hungry, or medium and medium power hungry, or very low power but pretty slow. And effectively, we were able to do that for ourselves, and a whole chunk of the chip is full custom, but we also designed our own cell library in order to be able to speed up bits of random logic and use PLAs. So one of the, I didn't do this at Plessi, I designed design flows, but we evolved a design flow and it got better and better. Now, I have to be honest and admit it, it wasn't absolutely fault-free, the first ARM. It had a bit of a problem with the state. I can't remember whether the status bit got trampled over or what was coming out of the barrel shifter. But anyway, I had this neat bit of logic. It just wasn't 100% correct. We were able to work around it, but thereafter at ARM, I would always put my hand up, because you really, if you're not making mistakes, you're not trying hard enough, but you don't want to make the same mistake twice. You don't want a blame culture. That's absolutely the wrong thing to do. We also had a problem with the bomb pads. And if the signals were ringing, coming in and out, then you could get it could occasionally latch up, and latches. When latch up basically means the whole chip turns into a connection, and then it stops working. The other good thing was, as we evolved, we acquired someone from Lee's group, because he was doing the synthesis of how you generate chips, and so we got Harry, who has a lot of experience. Two people that I worked with came from Acorn. The reason I haven't named Dave and Jim, the reason I haven't named the two that started at the beginning is, well, one of them just sort of disappeared, and I've tried tracking him down, but I haven't been able to. And the other one had an argument with the technical director and then left fairly swiftly after that. So swiftly that I was asked to escort him out the building, and then, and can you take over the group? There are interesting challenges about managing people you are friends with and colleagues with, but yes, it seemed to work out, and it worked out. And I absolutely liked these two guys when they're talking about, you build up trust and you work together, and yes, you might have some sort of framework, but it's not, you don't do silly things, you just trust each other and work with each other in the way that really works, not in some sort of artificial bureaucratic way. And I'm sure they didn't sort of do stupid things, but well, they might have done. Well, they might have done stupid things, but in the spirit of moving forward as well. Yes. Whenever. So coming up to the birth of the chip. So one of the hassles we had. So we send the data off to VLSI, but we couldn't do what's called design rule checking. Are all the separations of the transistors and other connections correct? And we couldn't do a simulation of the chip. And basically, you feel naked if you think you're going to. I have taped out a chip without doing any of that, but that was a special circumstance. And we ended up having to go to Munich because Lee had a VAX 11 750, but our Apollos just weren't enough for the job. And I suppose we probably could have got the software to run on it, but that would have cost Acorn more money. So we had to go out to Munich, to VLSI's offices in Munich, in order to run the simulations. I don't know if yours was particularly difficult, but VIDSI, it would take 8 hours of simulation. And so Tudor and I would go to the office, do something, set it all up running. 8 hours later, we'd come back, see what's happened. And these are not problems with the actual design. They're more problems with how we've set up the test patterns. And we did that sort of for several cycles of just getting back there, because you want to absolutely optimize the time you have in running it. But as part of the process we evolved, it worked sufficiently. One of the other good things is no one really talked about it, but we on the video controller we put video DACs. That makes sense, although putting analog and digital together was a little bit unusual in those days. And we also put a sound DAC on it as well. So the video controller also did the sound, which is a sort of classic, I think anyway, a classic sort of optimization that you can do when you own the system. You know, and I don't mean we owned it, I mean Acorn or the people working on it owned the system. The other interesting thing was the architects of each of the 4 chips. Mike is one of them at the back, Steve, Alistair, and Tudor. They were all different people to work with. They all, one of them, he'd virtually want to know what every transistor we've designed and put in did. Mike would, here's the spec, now to get on with it. Which is fine, and if we thought we had problems, he'd be there to talk to. But Steve was somewhere in the middle in terms of wanting to know what's going on, but also fairly busy. One of the things we got good at is delivering on time. I think it's because what we did was we used to split up the blocks between people. If someone had worked on something on the first chip, we wouldn't expect them to do the same again. We'd move around. We would use, I know these software people have another use for the term dynamic reallocation, but we would use dynamic reallocation. If people were struggling on a bit or it was hard, we'd shuffle people around. Everybody accepted this. The belief was, we operate in the belief that we all fail if something fails. So we had a lot of interest in looking at each other's work, challenging it, but challenging it in a nice way. Well, could you have done that better? Could you have done that smaller? In fact, I once challenged a colleague. There was a particular standard cell, and I said, you can get that down at least 25%. No, you can't. So I stayed until about 4 o'clock in the morning until I had exactly done that. Now, there are reasons why it might not have been a good thing, but it was okay in the end. And so I, very quickly, Acorn at that time was also going through its struggles. In fact, one of the things I'm pleased to tell you is I didn't sign that NDA letter that everybody else seems to have signed. And so I'm actually allowed to talk about this, but they mustn't be talking about it. So, I'll protect you. You can claim I divulged all this information. But what we ended up with the chipset, it worked. There's some stuff about one operating system and another, ARCs and Arthur, but we were getting despondent. There was one day that one Friday actually, Steve came down and said, you probably need to take all your personal belongings down. You know, we might not be coming back. At the same time, I don't know why, I think it was the marble slab in the corner of the office. We had Shirley Williams, we had Paddy Ashdown, we had John Knott, all visit, and clearly we must have been the more presentable corner of the building we were in. I can't remember them being particularly messy elsewhere, but we must have been. And we thought, that's it, you know, they're going to get rid of us as cost. Various business plans. Steve was one of the ones who was still there at the time, but it looked almost impossible. Some of my colleagues had got job offers elsewhere because it was looking bad. Unfortunately for us, Apple came along with a need, and the rest is history. I mean, I'll talk more about the rest of ARM, but I was going to stop at the 40th anniversary of the chip. Any questions?
I'm fascinated about the licensing that you kept on referring to, and the fact that because you had started from a clean sheet, you weren't constrained by
Sorry, I am listening to you.
rules coming in from anyone else.
I've got a prop. So the ARM chipset was first licensed by Acorn to VLSI Technology, the people who fabricated it. And they paid some money, but I wasn't going to get the money. I wasn't interested in that. What was the thing I was interested in is we could get them to do a full characterization of the chip, which if any of you have done chips that go into production is really important. It's got to work over a range of temperatures and voltages, etc., etc. And indeed, that's what they did. And this, I think, is 96, but it somewhere or other, it'll probably have all the specs. Actually, it doesn't appear to have much of the timing, but that's what I wanted out of it, because 50,000 chips might not seem that much in the light of the situation ARM are in at the moment. I mean, the good situation, but it's really vital. And so there was already a license, a plan, and that was it was a license fee and a royalty that was done as part of Acorn. That all got transferred to ARM. So that's the foundation on which we built. And in the early days of ARM, we talked quite a lot about, should we make chips? Is licensing going to work for us? And one of the big changes in my life, I've never wanted to be a salesperson. If I was honest, I'd say I look down on them. But Robin asked me to do the sales because we needed to cut back on all of the business of recruiting VPs of this, that and the other. And so I changed my job in order to do that. And yeah, it's, again, I think it's part of the spirit of as a group of people, you do what you need to do rather than what you think you want to do. It's about the whole. So so the first license was before ARM. The second license was at the time of the creation of ARM with VLSI Technology again. And then the third license, but second semiconductor company, was Plessi. And that took, I don't know, 11, 12 months. At one point, I think we were worried that we were going to run out of money. And we asked everybody if they would accept, I'm going to get kicked off, if they would accept not having a pay rise, because there's a kind of general acceptance of people like pay rises every year. And everybody said yes. We did license them in the end. It's just they were a very conservative company. So,
Jamie, thank you very much.
So, Sophie, what's it like to be looking back on 40 years?
It's like being 40 years older.